What does it mean when weather people say we're an El Niño and La Niña in the United States? That's what we're going to talk about today. Hi, this is Jill from the Northwoods talking about nature right outside your front door. And I can tell you that right now it is right outside my front door. I knew this winter was going to be terrible. Well, I love this kind of winter, but terrible for most people. Most people don't like extreme cold and extreme snow. Foot of snow on the ground, and it is going to be -3 tonight. And I knew that it was going to be a rough winter and bought new jackets because I lost 80 pounds. So I bought all brand new jackets because it's going to be a La Niña winter. And my friend was like, well, I don't know why you just don't wait a little bit because, maybe you're going to lose a little bit more weight. And I'm like, no, I need new jackets now before La Niña winter sets in. And boy, it came in fast and it hit us pretty hard. And we're going to talk a little bit, what is El Niño and what is La Niña and why does it affect the weather in the United States so much? I would love to do podcasts about these kinds of effects all over the world. I just don't know a thing about them. This is me doing a lifelong of learning about various things of nature. I don't know anything about what goes on in the weather in other parts of the world. So I can only talk about what I know. You could probably check out if you're someplace else. What does it mean for you? So first of all, when it comes to El Niño and La Niña, the trade winds are the very first domino to fall. Normally, there's a strong trade wind that blows from east to west and across the tropical Pacific, and it pushes warm surface water towards Indonesia and Australia, and that helps the snow pile up over there. And if you were standing in the reef, essentially in the western Pacific, at sea level, you would see that it was like a foot higher than it would be near Peru. That's how much warm water gets pushed into the west. This produces a temperature gradient. So it's going to be warm in the west and cooler in the east. The Pacific default state is that's the way it's supposed to be. But then the ocean pushes back, quite literally. Warm water doesn't just sit there. It has to go somewhere. And so it stores an enormous amount of heat energy, and it's even more than what the atmosphere can do. The atmosphere is very spread out, and in the ocean, this concentration of warm weather is also going to try to spread. In science, we go from high concentrations to low concentrations. And so then if the trade winds weaken, only even slightly, the warm water sloshes back eastward, and that is the start of El Niño. If the trade winds strengthen beyond the normal pole, it pulls even more warm weather west, letting the cold weather surge in the eastern Pacific. That's La Niña. That's what we're in right now. They expect with our current forecast, because our weather service does a La Niña, El Niño forecast, that it will be particularly strong La Niña through the beginnings of next year and into early spring. And then they'll do another forecast. Will it recede back into neutral or will it go towards El Niño? That's what we don't know yet. And so that's where this whole thing becomes kind of the steering wheel of the weather that we see. So this is called a thermocline tilt, and it's like a giant diving board. It's a metaphor that you imagine this huge underwater ramp, the thermocline, and the boundary waters where this warm water on the surface sits. Remember, warm air, warm water rises to the top of cold. Cold sinks, warm rises, just as a general principle. So then this thermocline in the deep west, because the warm water piles up, it starts to pile up and it shallows in the east. It builds up in the west. And this is where these upwelling brings up the cold weather or the cold water up. During El Niño, this ramp flattens, so the cold water can't rise in the east as easily, and the surface warms. During La Niña, the ramp tilts even harder, and the upwelling becomes supercharged, and the eastern Pacific gets extra cold. So this is the kind of ocean seesaw that's going on. It's different than the oceanic conveyor. Let's not get confused with the last podcast. It's a different kind of thing. And so then the atmosphere amplifies whatever the ocean does. So if the sea surface is warm in the east during El Niño, more evaporation, more thunderstorms, more heat is pumped into the upper atmosphere. Then the shift of the global wind pattern bends around the jet stream, and the disruption causes rainfall across certain areas of the continent. During La Niña, the opposite happens. Storms cluster around Indonesia, the eastern Pacific stays dry, the jet stream shifts north, and the air spills into the northern United States. Jill from the North Woods, right? So that's what's happening right now. All the cold air is spilling into the northern U.S., and it is chilly out there, I can tell you. So the atmosphere takes on kind of this hint from, like I said, I anthropomorphize everything, but it takes its lead from what the ocean is doing and magnifies it. And this is a feedback system, like a two-way feedback system. And the meteorologists call this feedback the Bjerknes feedback, or it's Bjerknes. You can tell me if I said it wrong. I probably said it wrong. But it's basically the way it amplifies itself. And so why does it oscillate? It's sort of like a pendulum going back and forth and back and forth. But the system's essentially just overshoots. After a strong El Nino pushes warm water east, the trade winds often roar back stronger than before. And this leads to rapid cooling, enhanced upswelling, and a snap into La Niña. After a strong La Niña piles up the water in the west, its system is primed for weaker winds, it sloshes back east, and there's an El Nino flip in there. That's why these phases don't last forever. That's why they flip-flop and sometimes go to neutral, and it's always trying to rebalance, overshoot, and overcorrect, and overshoot again. And so this natural pendulum is a rhythm that is roughly 2 to 7 years. We had, I forgot, the time span of it, but we got these polar vortexes probably about a decade ago, and real huge blasts of snow where I live. And it was the longest La Niña in the history of when we could record La Niñas. We had polar blast after polar blast. I've lived in this house, let's just say for 30 years. 30 years? 40 years. 40 years I've lived in this house. No, not 40 years. Let's say 30 years. Yes, it's 30 years. And when we got that really big La Niña burst, my pipes burst in my downstairs bathroom for the first time ever. And I had to do a bunch of things with a plumber to get that fixed up. We had terrible snows and terrible cold, and it lasted longer than anything. But essentially, typically, that's not typical. Usually it sort of, like I said, bounces back and forth every couple of years. And that's why, when we think about this ocean having power, it's a deep power, but it's also that the atmosphere is so tall. And so 1 degree shift in the ocean temperature and the winds drastically affects hurricanes, how much snow we get. And so that's essentially it. This El Nino and La Niña pattern are the rare places where the ocean sort of has a quick reaction. Usually things when it comes to the way weather works is slow moving, and instead this is pretty rapid. So again, the winds are always pushing, the ocean is always pushing back, and the atmosphere is amplifying exactly what is going on. So it makes it even bigger. So there is something that is called the ENSO status. This is the government, the National Weather Service's prediction model that it has. So when we see La Niña, like we're seeing right now, we'll see the conditions are the surface temperatures are an anomaly in this Niño 3.4 region are 0.5 degrees Celsius negative. And that is the current where we're at right now, the Climate Prediction Center. These La Niña conditions are expected to be not as strong as it could be, but like I said, they're sort of building strength, and that's why all of a sudden our weather just shifted drastically. And that gives the forecast, like I said, a moderate to high probability that La Niña will continue, and it's going to continue November through January. It expects a transition to happen to neutral, which means that it won't be El Nino or La Niña, somewhere in the January to March region. And that probability of an upcoming El Nino, though, is low in the summer, which we'll talk about why I think that that's good news, but maybe you don't. So because La Nina is weak right now, we can expect that it'll fade to neutral. This is a classic La Nina signature, but like I said, back in I think it was like 1990s, we had a really drastic La Nina that just lasted, I think, 12 years, which was the biggest La Nina we ever saw. And in fact, it was kind of funny because some of the forecasters were saying, "Oh, we might never see a La Nina again." And instead, we saw the biggest, deepest, most pronounced years of La Nina ever. And so that's going to be kind of interesting. So we're going to talk a little bit about what we can expect when we have a La Nina situation in wintertime and what a weak La Nina and a transition could mean for summertime. It changes how birds, wetlands, can mean for everything. There's subtle nudges all over the place when it comes to timing, the snowpack level, drought levels, where are droughts happening? And just, from a kind of interesting thing, I have friends in LA, and when we have El Nino, it gets dry and hot here in the North Woods. It gets wet in Los Angeles. That's when they got all that amazing rain. When it shifts back to La Nina, we get walloped with rain and snow and cold, and LA dries out. So it affects all sorts of different scenarios. And there's a lot of good reading out there on the internet about what El Nino and La Nina mean. And you can check the National Weather Service, and they have good explanations of where we are right now. It is the ENSO, the ENSO Prediction Center, that talks about where we're at. So essentially, that's what's happening in this story of these transitions between this El Nino Southern Oscillation, which is the ENSO, and all of that, and see where we're at, and keep your eyeballs on it, because it's going to probably tell you a little bit about what kind of summer and what kind of winter you're going to have. And if you're interested in where they got that name from, it's kind of interesting as well. Essentially, Peruvian fishermen noticed that the warm water years before this happens, they called it El Nino, which means in Spanish, little boy, which was to represent the Christ child, because the warm winter water tended to arrive around Christmas time. So that's how it's got its name. But where it affects the weather is we'll talk a little bit about it in general. El Nino tends to bring wetter, stormier conditions to California, mostly Southern California, warmer, milder winters in the northern United States. We might not even get snow. We might get a little bits of snow here and there, and it won't be drastically cold. Fewer Atlantic hurricanes, more Pacific hurricanes, rain relief in parts of South America, and droughts to Indonesia and Australia. So when I was a kid, like I mentioned in the last podcast, we had 310 inches of snow. And in that particular case, that winter of 1977, that wasn't El Nino either. I said it wasn't the oceanic conveyor. It also wasn't El Nino. But the North Pole was flipping its climate pattern, the Great Pacific Climate Shift. And so that's a whole other story, too. So I keep, trying to get to the bottom of why we got 300 inches of snow when I was a kid in the North Woods. So La Nina does the exact opposite. It tends to bring colder, snowier winter to the northern United States. Fact check true. It spikes the Atlantic hurricane activity. It dries out the southwest of the United States. And it triggers Australian rain. So it's one of the most interesting things, like I said, and I just love watching the forecasts every year because it gives me a little idea about what to expect. There are different things that people will do when they're looking at these patterns. They keep a coral diary so they can see how the coral skeletons grow or shrink based on the El Ninos, and it almost acts like tree rings to these paleoclimatologists, meaning that they're sort of doing climate archaeology to read how El Nino and La Nina were hundreds of years ago. El Nino can change the bird migration. So warm weather shifts, it shifts the population of fish. So you might see seabirds get rerouted. So, albatrosses, petrels, those things will get rerouted. In the North Woods, we can also see water birds in this pattern use this upshifting stream to go into different directions. El Niños has, like I said, some of these megacycles, and no one really has the complete puzzle of it yet. We're learning more and more about it. But we're going to talk a little bit about, like I said, what exactly it does. Scientists now use the El Niño La Niña forecast to look at crop strategies, river management, wildfire outbreaks. Remember, we had really bad years of these Canadian fires. I'm guessing that those are El Nino years. Mosquito-borne disease tracking, emergency planning for coastal cities. This ENSO forecast with the warmer Pacific can basically shape so much of what's happening in our weather in a much more quicker way than we're used to seeing for that particular piece. To do a little bit deeper dive on what changes, because we talked about how it changes weather, I wanted to show you how it affects it. So when we have El Nino, the Pacific jet stream is a roaring river of wind. We had a jet stream podcast a few weeks ago. It slides farther south than normal, and then that one reshaping of the jet stream sends more storms into, like I said, Southern California, and the northern tier loses its parade of cold blasts. Pilots can also use this ENSO conditions so that they know over the long haul what the tailwinds are going to be. The southern states in the United States become storm alley. We're going to see a lot of storms going all the way, I think, from Texas through the Carolina coast, storm after storm after storm. California gets that atmospheric river. The Southwest even maybe will get rain and break some of the drought patterns. The Gulf Coast will see more storms than normal. And the Southeast gets particularly soggy. That's why fire management becomes a big deal because, like I said, we noticed that the Northern California, northern in Canada started ramping up their fires. And that's why we had so much smoke this particular summer because El Nino had been the pattern and was starting to fade, but it was still in presence. The northern United States, like I said, we'll have a warm, mild winter, and we won't have as much snow. That might even lead us in the North Woods to get drought. So we had been, during El Nino, particularly droughty, and we were starting to get into some fire damage. But we were also not having cold snaps, and spring came early. And I remember one year I actually got my biking season going March 3rd. They call it a flattened winter, less dramatic, fewer temperature going on. During strong El Niños, which, like I said, we had, maybe like I said, 3 years ago, maple syrup in the New England can start to early because the sap starts flowing earlier because we're not having such a cold winter. The Atlantic hurricanes calm down, and during El Nino, we just won't see as many of them, which also means that there can be droughts to certain areas, but it also means weaker storms, fewer storms, and it's easier on it. You can see that La Niña was building its way in because what did we have? We had some very strong Atlantic storms right at the very end of the season. And tornado patterns can shift. In El Nino years, we'll see fewer tornadoes in Tornado Alley, and we will see them more in the Gulf states. We will see a lot of activity happening around Florida and that area. So it happens all the time. The Pacific Northwest tends to dry out a little bit. It gets a little bit drier, a little bit less rainy. All the vampires living in the Pacific Northwest are going to have to hide because it means more sunshine. And some of that also can hurt the hydroelectric generation in places like the Columbia River Gorge, which I think that they're ripping out a lot of those pieces. Mount Rainier will probably leave it with very thin snow. It won't get as much snow. Like I said, here in the North Woods, we tend to get, and that's Midwest, by the way, warmer winters, fewer snowstorms, and it just could be, if we get snow, it's going to be sloppy and wet. And then the snow goes away very early. And then, like I said, early spring. And that has a dramatic effect on the Great Lakes just in general, which we won't talk about today, but that's the idea. It was during El Nino that we have had the Great Lakes struggle to freeze, but that was like 97, 98, where the record ice hit record lows, and you hear about it all the time in the news. But right before that, in the last El Nino or La Niña situation, the Great Lakes froze harder than they had ever frozen before. And so that was kind of interesting. Alaska gets a big chill. It puts Alaska in a cold dome. Colder than normal, drier than normal, and really deep, persistent cold spells. And in the desert Southwest tends to bloom. It tends to bring rain to the desert. I remember I was in Los Angeles after we had one of these years, and the Saddleback Mountains were painted in purple and yellow. It is beautiful when you see what flowers can bloom in these very dry, deserty areas. Everything from poppies to lupines to brittlebrush, and the hills were gorgeous. So that doesn't happen all the time, but that certainly sets the stage for it. And then farmers also can reshape what it is. We lose snowpack for irrigation in El Nino, which means that we're probably going to have to do more irrigation, and we will have a longer growing season but less water. So California fills its reservoirs, and then we ended up very dry and droughty over here. So you can imagine that insurance companies are doing a lot of study about the ENSO pattern seasons every year so that they can sort of figure out what's going to happen next. Then when it comes to La Niña, that flips the script on it all entirely. Like I said, now we're in La Niña. So the jet stream shifts north, it strengthens. This is a big move, and the Pacific jet stream goes up north, becomes straighter, becomes faster, and then we get this storm conveyor belt, which we're in right now. You can see it. They've sort of predicted our storm thing. We are getting bunch of snow, cold blast, bunch of snow, cold blast. That is what is expected for us all the way through the end of the year. We're about 3 weeks out to the end of the year. We are in that ribbon of continuous storms coming this way, which I just love, by the way, but nobody else does. So this jet stream speed up then shaves significant time off the Asia to U.S. flights, which is interesting by itself. I've been in the other situation where I was supposed to fly to England and it was going to take 8 hours. I was there in 6 hours. So, anyway, you get different situations that are there. It's a gift for snow lovers, particularly me, and it means frequent Arctic outbreaks, deeper cold spells, heavier snows, Rockies, Great Lakes, Midwest, and the Northeast, thinking about Maine, New Hampshire, greater snow frequency in the Northwest and in the North. Boy, I just love it. Feels like real winter now. We are definitely going to have a very, very white Christmas. I like to get out and cross-country ski. It's going to be a good cross-country ski year. Lake effect snow, which means cold winds blowing over the Great Lakes, produces even more snow, and they are getting blasted as well. The Pacific Northwest gets hammered with rain, Washington, Oregon, and then eventually it will bring those strong atmospheric rivers, persistent rain, heavy flooding, and heavy mountain snowpack. Hydroelectric planners and ski resorts love La Niña years because it's going to mean it's a good year for them. However, in Southern California, it's going to mean dry. It's going to get drier, droughtier. That's when the big fires happen down there. It can cause the reservoirs to become uncertain about whether they get refilled. And La Niña years have been notorious for a lot of fires in Southern California. The Sierra Nevadas pack more than usual. One of the times when I was out in Sacramento, the Tahoe area in the Sierra Nevada had 270 inches of snow on the ground, and it was busting in roofs, and ski lodges had to actually cancel skiing because the snow was coming up all the way up on the snow lifts where they were supposed to swing your legs and go up the ski lifts. They were so full with snow they couldn't get up the ski lifts. So that one was a really drastic version of it. New Mexico, Arizona, West Texas, Oklahoma slip into drought, dry weather, fire risk, low soil moisture, and dust and wind events. Firefighters pay close attention to La Niña in these areas because they're looking for signs of fire. The southeast becomes warm and dry, so we'll start to see droughts happen in the southeast, which usually they tend to be very lush and very green and lots of water. They have dry spells, and it can increase their fire risks as well. So that's why Florida winters during La Niña tend to be wildflower times for it. The Midwest, where I'm, colder north, warmer south. So there tends to be a split between it. And north of that split, colder and snowier. I am north of the split. And then where you see in the southern part of the split, they tend to be much much easier. They warmer, drier, like I said, fewer snowstorms and more seesaw winter temperatures. But I am north of that split. And right now we were watching it. My friend and I went out bird watching, and we could see the jet stream cloud line, and it was creeping all the way up north all day long yesterday. And then we got walloped with another 6 inches of snow, and now we're going to get a huge blast of wind. For the Northeast, it's not quite that simple. They do get big nor'easters. They also get longer dry spells. They don't get quite the effect we do here in the Midwest. They might even get some warm spells that will melt the snow early and then suddenly get a blast of cold air. So really for New England, it tends to flip-flop their weather back and forth. And you can kind of think of that boundary of I-95, and then that cold rain kind of just oscillates right there. For us, it's more like I-90. Is it going to be above or below I-90? The Atlantic storms get a power boost, and the Atlantic hurricane activity increases, the wind shear decreases, major hurricanes become more likely, and we'll see long track hurricanes, right? That's what we saw at the end of hurricane season because La Niña was building up. In the spring, it tends to mean that tornado alley starts to creep up. And so you'll see big tornado storms in Texas, Oklahoma, Kansas, Nebraska, while for the past couple years while we were coming off of El Nino, it had been Iowa, Minnesota, Wisconsin. So it's really wild how this weather just kind of moves up and down. The Corn Belt farmers won't have to worry about dry early summers. The California farmers are going to pivot to irrigation plans. The Texas ranchers brace for drought. And the citrus growers in Florida are dreading hurricanes in their part of it. So really, like I said, we can kind of predict what kind of year it is. When I saw that La Niña was building and building significantly, I ran out and bought a bunch of new coats because, like I said, I lost 80 pounds and none of my other coats fit. Last winter was El Nino. I didn't even bother getting a coat. I knew I'd be fine. This year, coats galore because it is going to be a blast of cold air all the time. So that makes it kind of fun. There were significant historical events that had to do with El Nino and La Niña. And we know now, like I said, because we have methods to see how strongly they were in the past with these paleo climate people. There was a super El Nino that happened in 1997, 1998, and that we had record warm. Usually we sort of get where I'm at, like 3 days with 90s in the summer times, and maybe we get 3 days of 100 in the summertime. Rarely, though. That year we got blasted. We were drought. There were fires happening here. We had to leave water out for all the different animals and everything else like that. The northern United States, that's where I ended up biking in March 3rd. Spring was so early. We barely dipped below, and I was able to go biking really early in the year. And in early 1998, Lake Michigan hit the lowest ice level it had ever had. 2015 to 17, El Nino went ballistic again. They called it Godzilla El Nino. The southern United States got flooding. Pacific Northwest stayed dry. Alaska got extremely warm. The tornado pattern shifted, which is a big deal to us because we can get tornadoes here. And California got that huge wet season that they expected. There was years like 1973 to 1974, the coldest winter, and El Nino and La Niña delivered a brutal cold winter to the northern states. There was a 1974 super outbreak of tornadoes, April 3rd to April 4th, and it was one of the biggest, most violent tornado outbreaks in history, with 148 tornadoes in 13 states in less than 24 hours. And why did that happen? Because of La Niña. So this is really, and you might have heard about some of the tornadoes, the Xenia, Ohio tornado footage, which was one of the biggest, most classic tornadoes we have ever seen, came out of that year. 2010 to 2011, La Niña met Snowzilla. The winters were, like I said, were terrible. We were buried in snow. The Midwest had ice storms. The South had a rare snowstorm, and the Pacific Northwest was drenched. 2011 tornado outbreak was another one of the most historic outbreaks ever recorded in history. And that was where the Tuscaloosa and Joplin events came from. That was a La Niña winter or summer. So that was pretty terrible. I will never forget that summer. And in 2020 to 2021, La Niña was happening, and it was the northern states. We had snowy winters. The Pacific Northwest again got soaked. Texas had severe droughts. And in February of 2021, Texas had a deep freeze. That temperature plunged, and the power grid failed, if you remember that. And that was a once-in-a-generation cold wave that hit Texas. So all sorts of things can happen in this particular case where we see these weather patterns change. I hope that's been interesting to you, that you can just change weather based on whether it's El Niño and La Niña. And you can, like I said, for the most part, tell where you're at just by looking at the weather. But you can also go to the National Weather Service and check out their ENSO forecast. Thanks so much. Thanks so much for watching. I hope you enjoyed this. If there's other topics you would like to learn about, you can leave them in the chat channel. Let me know what you would love to hear about it. I would love to talk about nature right outside your front door, too. You can email me at jillfromthenorthwoods.com, and I would love to hear from you. Thanks so much and have a great day.